Hello everyone. Today we're going to be going over a systematic process to find sine, cosine, and tangent for any kind of special angle. So firstly, you should plot it on the unit graph, the graph of the unit circle, and see where the line comes out to. For example, we're going to try and find the sine, cosine, and tangent of 315 degrees. So we know theta is going to be 315 degrees, which is going to be 45 degrees away from the starting point if you were rotating clockwise, and so the line would be here, and you would get a triangle like this. So first, plot on unit circle. And I know this may be very familiar to you, some of you who have watched my videos before, but this is a review circle to reinforce the points. 2. Identify which special triangle is being used. For example, you have the half equilateral triangle, the 30-60-90, or 90-60-30, no matter what you want to say, it's the same. You should identify whether it's this triangle, which has the side ratios of 1, 1/2, and root 3 over 2, aka 2 to root 3 to 1, or it could be the right isosceles triangle, the 45-45-90 triangle, which is the one we are using at the moment, because it's going to be 45 degrees from the nearest coordinate axes. So this side will be 1, and this side will be root 2 over 2. This side would also be root 2 over 2. And the reason here is that in the isosceles triangle, since it's also a right angle triangle, we can apply Pythagoras' theorem. We know that 1 squared is going to be equal to a squared plus a squared. And we know that a is positive because it's the length of a side. Or 1 is equal to 2a squared. A squared is equal to 1 over 2. A is positive root 1 over 2, which is going to be equal to root 2 over 2 after you do all your surd simplification in that. So like, just do that sum and you'll be able to find out why this is root 2 over 2, and you'll be able to rederive it quickly in an exam. But yep, so this is the triangle here. It has side length ratios of 1 to 1 to root 2, and that's the other special triangle we can use, and we know that's our special triangle. And then 3, find the positivity or negativity of sine, cosine, and tangent. So we know that since this is underneath the x-axis, sine will be negative, and since we know that this is to the right of the y-axis, cosine will be positive, and tangent is sine over cosine. It's a negative over a positive, so it is also a negative. And then 4, we can apply this knowledge as well as the special triangle we are using to find the final values of sine, cosine, and tangent. So for example, sine, the negative, will be negative root 2 over 2 because it is the vertical side. Cosine will be positive root 2 over 2 because it is the flat horizontal side. And finally, tangent will be negative root 2 over 2 over root 2 over 2, and these two cancel out and these two cancel out, and you'll get negative 1, which is tangent of 315 degrees. And that's basically all I wanted to go over in this video, and hopefully you will know how to find these special trig values, and you'll be able to evaluate things much quicker in the exam, and it'll be much more instinctual to you. And that's kind of the purpose of this video. And in the next video, we're going to get started on applying all this foundational trig knowledge we've learned in the last, I think 12 videos it is. We're going to be applying all this foundational trig knowledge to start looking at problem solving. Alright, so thank you for watching.